So I think we can start now, sir. People are still joining, but we can start. So uh, we have already a session from Jiten sir yesterday, but I will quickly give brief introduction for sir. So sir is currently serving as assistant professor in Department of CS at BIT Mesra Jaipur. He is an accomplished academic with a strong background in blockchain technology, IoT security, and cyber forensics. He holds a PhD from MNIT Jaipur, where his research focused on developing a secure framework IoT using blockchain technology. Throughout his career, Sir has worked with several prestigious institutions, including MNIT Jaipur and IIIT Kota. He is also a member of professional organizations such as IEEE, the IEEE Computer Society, and SCRS Society. So, handing over to you, sir, for further proceedings.
Yes, Mr. Agam.
Yes, sir.
Yes. So, should we start or like?
Sir, we can start now.
Okay. Okay. So, good morning all to all the participants. So, for today's session, we will continue with the risk management in the cloud services, and then we will discuss about some cryptographic primitives in the cloud security. So, first, is the slide completely visible, Agam,
Yes, sir.
in full screen or
No, no, not in full screen, sir.
let me okay, so I think now this one is the full screen now.
Yes, sir.
Yes, okay. So in last lecture we have discussed some cloud security aspects, how to provide the security to the cloud. So in today's session we will discuss risk associated with the cloud security, how to identify the risks, and then how to manage the uh, vulnerabilities assets in our cloud system. So first of all, the definition of this cloud risk management is we have to identify our all potential, identify our vulnerabilities in our system, and then we have to find out the threats, and we have to minimize these threats by identifying these threats. So basic objective of this risk management is to protect our data and application and infrastructure from these threats. So the basic steps involved in this risk management is first we have to identify these security risks. Those are in our cloud system. After that, we have to assess these security risks, means what is the uh, impact of these security risks. After that, mitigation strategy we will what risk mitigation strategy we will apply to remove these risks, and there will be continuous monitoring and improvement to the system, existing system. So next is first step is identifying cloud security risk. So first we have to list all the assets of our cloud system. That assets may be data, that asset may be infrastructure or application or the network services. So first identifying all the assets, Then identifying the threats, what threats can be there, like unauthorized access or data breach or unencrypted data. So we have to identify all the threats that can be happen on our system. Then we have to evaluate the weakness of those weakness of our system that can be exploited with by the threats. And then there will be some tools and techniques that will there will be some tools and technique that will automate the scanning process, and manual assessment of the vulnerabilities will be there. To detecting these vulnerabilities, we will apply those tools and mitigate the risks. So when we analyze the identify all the assets, those can be reached. So after that, we have to analyze what kind of risk can be there. So we have to identify the level of the risk. So what level of risk is there? The risk may be based on the severity of the attack. So that may be critical risk, or that may be moderate, or that may be of the low level risk. So according to the level of the risk, we have to take the action. If the risk is critical, then we have to take the action within the time, immediately on that risk, on that attack. If the risk is a lower priority, then we can take some time to implement that risk. So there are some standard frameworks. So we have to apply standard frameworks to identify, to identify our risk associated with our clouds. So one framework is NIST SP 830. So this one is NIST SP 830, that provides the guideline for conducting the risk assessment. So how to assess the risk? These guidelines are provided by this NIST SP, and there is complete documentation of this. This one is a complete standard document or framework that is provided by NIST for the risk assessment. So the URL is given here, so you may check out this risk assessment framework provided by the NIST. There is one more standard, that is IES 27005. So this information, uh, this provides the guideline on managing information security risks. So how when first step was identifying the assets, then identifying uh, second step was assessing the cloud securities, identifying the level of the risk, and the third step is we have to mitigate the risk. So what mechanism can be there to mitigate the risk? Again, we have discussed these type of mechanisms, like we have to implement access control policies, either role based or location based, or we have to encrypt a data encryption mechanism. Either we may implement triple DES, AES 256. So any encryption mechanism we may opt to protect our data. There will be regular assessment of these mechanisms and these frameworks. Then we have to divide for mitigating the risk. A network segmentation is also one method in which we divide our entire model in multiple segments, and we analyze a specific segment for a specific time if there is any risk identified, and there should be proper response planning should be there. So if any risk is there, then within that how much time we have to take the action. So after that, there will be continuous monitoring, regular auditing, and employment training will be there to mitigate the risks. So next is compliances in the cloud. So we have to follow. There are some compliances that has to be followed by the cloud service providers. So these cloud service providers should be adherence to these standards and policies to protect our data over the cloud. So why we use this cloud compliances? So the importance of using this cloud compliances is maintaining these compliances helps organization to avoid legal penalties, safeguard sensitive information, and build trust among the clients and as well as the stakeholders. So if any organization following any compliance or following any standard regulatory SOPs, so if that follows the, so there will be lesser chance of the breaching of the data, and that also avoids the legal penalties that may be imposed by their government or that organization due to the breach of the data. So there are some guidelines for protecting the data. First is the GDPR, that is General Data Protection Guideline. So this protection guideline is for the personal data. So if any cloud service is storing the personal data, then he has to follow this GDPR guideline. So the key provision, key consent, key points of this GDPR is like we have to mandate explicit consent. So each and for data collection for each and every individual. If cloud service is storing the data, then explicit consent for the data collection should be there. And if there is any data breach, then within the 74 hours, that cloud service provider has to inform to their belongings to their belonging persons or individuals that their data has been breached. And each and every individual must have the right to access their data as well as to update their data and delete their data. So if any cloud service is using the data, so all rights related to the data should be available to the to a person, particular individual person that is related to the data is related to that person. Next guideline for storing the payment card industry, payment card industry data security standard, also stands for PCI DSS. So if any organization or any cloud service is storing the gateway information or merchant information, credit card information, debit card information, transaction information, so that organization or that cloud service provider has to implement strong access control measures. And also that has proper network security planning, and also regular monitoring of the regular monitoring, and the network should be tested on the regular basis. And that has to be provide some encryption, hashing mechanism, zero knowledge proof, like policies for for securing the data. So we will discuss these encryption mechanisms, hashing, and zero knowledge proof in our next part of this presentation. That those will be the part of the basic cryptographic primitives. Those are used in the cloud services. Next regulatory guideline is like for HIPAA, that is for health data. So if any organization is storing the health related data, EHR or electronic health records, so health insurance policy and commodity act is there in a US federal, that has some set of rules and policies. So the key provision of this HIPAA is like the data should be private. So that is that data should be private, and that should not be revealed to any person, or that should not reveal the identity of a person. So if for example, if I am storing my healthcare data like my pulse, my ECG data, my temperature, all the data related to the all the data related to my healthcare, so these data should not reveal my identity. Means by analyzing the data, the attacker should not be able to identify who am I. So physical security should be there, so to protect the confidentiality, integrity, and availability of the data. And each and every patient should have the right to control each and every patient. Here we when we talk about the person, then in HIPAA the person will be the patient. So that person has to be right to control their health information, to whom that can be accessed by. So if a person gives the right to a hospital organization, then that particular hospital organization will be able to obtain a copy of their health reports. No one else can access these health records. So there are several key aspects associated with the HIPAA. So how to implement these compliances in the clouds? So for implementing these compliances in the clouds, there are the responsibility are shared between the cloud service provider and customers. So regular audits and assessments will be there. Regular audits and assessment will be there for is that organization is adherence to the compliances those are opted by that organization. Regular training or awareness program will be there. There will be implementation of data encryption and access control policies. So basically, when a organization adheres to the regulatory requirements and implement these frameworks, so that ensures the person that the data is stored correctly and not breached by someone else. So there are several frameworks provided by NIST, CIS, and Cloud Control Metrics by CSA organization. So these provides the framework those provides the adherence the compliances to the cloud services. So we have completed our earlier lecture. In this lecture, we have analyzed how to identify the risk and then how to implement the compliances. So what are the compliances like for the protecting the healthcare data, protecting the personal data, or protecting the payment gateway of data. So for protecting each type of data, the organization had to adherence to the compliances, and according to compliances, they has to take the actions. So now next part is cryptographic primitives. Those are used in the cloud security. So next is cloud security. Okay, so this one, full screen. Okay, yes, Agam, are you there?
Yes, sir.
So now next we have started our next session on cryptographic primitives. Is this full screen visible?
Yes, sir.
Okay, okay. Today we will discuss some cryptographic primitives used in this when applying the cloud security. So what are these cryptographic primitives? We have discussed in earlier session, like there will be some regulatory, there we have to follow the access control policies, we have to apply the encryption mechanism. So how to apply, so what are these encryption mechanisms, how the keys are generated, how the keys are shared among the all the parties. So there is the cryptography. So the cryptography is the science to making that data secret or hidden. So hidden writing or secret writing is known as the cryptography. So the encryption is the process with that encrypts or that hides the data using any particular algorithm. So there will be a particular algorithm that provides that encrypts the data. So there will be as shown in diagram, there will be plain text and there will be one key. So a plain text and key will be provided to the encryption algo that generates this ciphertext. So this ciphertext is the encrypted data, and other side there is plain this cipher data is again the pass to the decryption algo, and with the respective key will be there, decryption key will be there. So with the help of these cipher text and key, using decryption algo, the plain text is again obtained. So for example, if A and B, two parties are communicating, means two persons are communicating with each other. So two parties are communicating each other, then they encrypts the data with their private key and then send that data to the then decrypt that data. So this encryption mechanism is also applicable over the clouds. So how to implement these encryption algo over the cloud? So when storing our personal data, then we have to encrypt our data using any private key, and encrypted data is stored over the cloud. And then when any person access that data, then he downloads or then that access that encrypted data, applies the decryption algo, and then decryption algo with the help of the decryption key, and they obtains the plain text. So this one is the encryption mechanism over the cloud. So we have to follow standard encryption algorithms to encrypt our data. So advantage to use the standard algorithm is like, if we use a standard algorithm, then the security of that algorithm will be higher. So this strength of this encryption algo depends on this key. If the key size is higher, then the encryption the breaking this encryption mechanism will be the higher. We need more efforts to break this encryption algo. So if for encryption and decryption, if the same key is used, in that case, that is known as the symmetric encryption or symmetric key cryptography. And where if the different keys for encryption and decryption are used, then these are known as the asymmetric key cryptography. So we will discuss some symmetric key cryptography algorithms and as well as some asymmetric key cryptography algorithms. So as, as so in symmetric key cryptography, the same key is used for the encryption and decryption. So example of this symmetric key cryptography or symmetric algorithm is Caesar cipher. We will discuss how this Caesar cipher works. Then these any cipher techniques can be divided into two parts. Either that cipher techniques may be a block level cipher or that may be a stream level cipher. So in block level cipher, entire data is divided into multiple blocks. So the block size may be either in multiple bits like 264 bits, 128 bits. So entire data is divided into separate blocks, and the encryption algorithm is uh, uh, applies to these blocks. Whereas in the stream cipher, each bit by bit or the byte by byte data is processed. So first byte will be there, then that will be encrypted, then second byte will be there, then next byte will be there, and next byte will be there. One by one each byte will be encrypted. So these kind of encryption mechanisms are known as the stream cipher. Whereas when the data is divided into chunks or the blocks, then that is known as the block cipher. So the the strengthness of this symmetric encryption algo depends on the key size. So if the key size is higher, then the encryption level will be the higher, and there will be more difficulty to crack that encryption algo. So generally the key size relies between 48 bits to 448 bits. So if the length is of 48 bits, then there will be 48 bits means the combination of 48 zeros and ones. 48 bits of zeros and ones will be there. So there will be maximum 2 raised to 48 possible keys. As shown here, if the key is of 40 bits, then maximum possible cases will be of 2 raised to 40 possible keys will be there to break any system, to break that system having the 40 key size. If we use 128 bit key size, then there will be 2 raised to 128 possible keys will be there, and there will be 2 raised to 128 keys will be there to break that encryption mechanism, to break that encryption process. So as we increase the key size, then encryption level also increases or the security strength also increases. So you can analyze that if we increase the bit by 1, means if 128 to 129, then the possible keys will be 2 raised to 129. So from 2 raised to 128 to 2 raised to 129, there will be exactly strength will be double to the previous key size. So with the each single increment in the bit, increase the strength by the 50 double of that existing security level. So what is the meaning of these possible keys? Means if any attacker attacks on that encryption mechanism, then that will apply the brute force mechanism. So in brute force mechanism, the attacker has to test all the possible cases. So all the possible cases means the person or the attacker has to apply all the possible keys. So if there is 2 raised to 128 possible keys, in that case, that will implement 2 raised to 128. That is itself very large value for itself very large value to test the to decrypt that data. So uh, from some researcher we have concluded that we some literature review we have find that a supercomputer can crack a 56-bit key in 24 hours. This DSA, there is one encryption mechanism, DES. Then DES has the 56 bit key size. So a super computer can break that 56 bit key in the 24 hours. So it will take 2 raised to 72 times longer to crack a 128 bits with compared to the 56 bits. So now we have stated that the seizure cipher is the symmetric encryption mechanism. So how this seizure cipher works? So this seizure cipher is basically a substitution cipher method. So in seizure cipher there is a plain text, and that plain text is increased by any key value. So for example, here if the key value is 3, then each alphabet is rotated by 3 times forwarded. So if a is, for example, there is a, then a plus 3 in alphabetical order there will be d, then b plus 3 there will be e, c plus 3 will be f. So in the as shown in diagram, so each this plain text is converted or substituted with these words. And then now there is one example, attack at down. So this one is a plain text, so we have to encrypt this plain text using the seizure cipher. So first there is a, so we will convert this a to the d, then there is t, then we will convert this t to the w. So let we have to check. So as here t and d, then sorry, a is converted to d, t small t is converted to small w, again small t is converted to small w. Okay, again a is converted to the capital A, small a is converted to the small d. So this one is the seizure cipher encryption mechanism where the key is 3. So similarly there will be one decryption mechanism. So in decryption mechanism there is again in decrypted text, this decrypted text will be there. So again decryption algo will be there that decrement the value of d by 3. So when d is reverse process, then d is converted to the a. So this one is the seizure cipher mechanism. So in this seizure cipher, so how many possible keys can be there? So to all the participants, so if we are using seizure cipher, so how many possible keys can be there? Any response from participant? Okay, there are total 26 alphabets. So 26 alphabets. So each can be incremented either by 1, 2, 3, 4, 5. So up to 26 possible cases can be there. So maximum of 26 key can be there. But when we use 26, then there will be again same occurrence will be there. So basically there will be 25 cases when we use this seizure cipher. So there is one more substitution cipher technique, that is monoalphabetic cipher. So in monoalphabetic seizure cipher, each and every alphabet is replaced with any random value, and these values has to be stored in a directory, so that with the telling each and every alphabet with their respective encrypted text. So there will be possible factorial 26 will be there. So the reason or why there are 26 pairing of the letters, the reason is like a can be converted to m, so b can be converted to remaining 25, so c can be converted to the remaining 24, d can be converted to the remaining 23, and so on. So by like this 26 into 25 into 24 up to 1, so there will be total factorial 26 pairs will be there. Okay, so this one is the example of this monoalphabetic. So here b is converted to the n in the monoalphabetic. So with the cipher mechanism, b is converted to the m, and o is converted to the k. So small o is converted to the small k. So this one is a monoalphabetic seizure cipher technique. So there will be this one is monoalphabetic, and this one is the polyalphabetic seizure cipher. So in monoalphabetic seizure cipher, each and every there are for each and every alphabet there are multiple decrypted tasks text. One for k equals to 6, a is converted to f. For k equals to 20, a is converted to the t. So there are different keys, and for each keys there is again one pair of mono alphabetic Caesar cipher. So if there are multiple keys, so this one is known as the polyalphabetic Caesar cipher. Okay, so here b is converted to the g, then o is converted to the. So there will be particular sequence of keys will be there. So the sequence should be followed while encrypting these. There in the Caesar cipher, the key is passed to the cipher algorithm. So there will be plain text, and as well as there will be key. And what is the key? Key is the sequence of these C's: C1, C2, C3. And what is C1, C2, C3? C1 is K6, C2 is K equals to 20, and so on. So there will be one sequence. So there will be sequence associated with these input alphabets, and with the sequence, with the key and with the input alphabet, and encrypted text is generated. So there is one example that is a substitution cipher using a keyword. So in the key substitution cipher, word is our key. Word is our key. So what we do here, we just find the word from these alphabet. We write the first word and then write all the alphabets a to z. So this plain text will be encrypted. This plain text will be encrypted with the help of this relationship or this mapping. So word is the key here. So if the key is word, then cipher algorithm itself firstly place the word, and then remaining alphabets will be there, and then each and every sequential alphabet is associated with the key, and we apply this encryption mechanism here. So earlier all was the substitution methods, where we substitute a input text to another input text. Next is the transposition. So in transposition, we just rearrange our input plain text. But in the case of substitution, we substitute that particular alphabet with the other alphabet. So in substitution, alphabets are replaced, but in transposition, the placement of these alphabets are replaced. So as there is one method, column transposition method. So in column transposition cipher method, we divide our plain text into a tabular way, and we convert this column to the row. So plain text is TSSOHOANIW. So we convert this TSSOHOW row wise. So TSSOH, then next is OANIW, then OANIW, then next column will be there. That column will be converted to the row, and so column wise column is converted to the row. So this length of the size of this matrix may vary. So here the length of the size of this matrix is 10 by 5, 10 rows, 5 columns, where so we can convert, we can opt any matrix size, tabular size, for converting the plain text into that tabular way. So what is the good characteristics of this? What is the good characteristics of good cipher algorithm? So the good cipher, when we state that this cipher algorithm is the good cipher algorithm, so when the size of key is higher, then we can state that the encryption algorithm is good. So there is a proper amount of complexity. A proper amount of complexity should be there. So if that is not much higher and not much lower complexity level, then we can state that that should not as much higher that a computer machine cannot be resolve that can solve that problem within the time, and should not be as easier as a human person can easily guess the output. So the implementation of these encryption algos should be simple as possible, so that a programmer can implement these encryption policies. And there is propagating of the error should not be there. If there is any error in any block, then that error should not be propagate in the next block. It means there should be no dependency between first block and the second block. So the dependency should not be there in the good cipher algorithm. And the cipher and the length of the cipher text should not be less than the original message. So that should be exactly equals to, we have to be try that the length of the original message and encrypted message should be equals, so that they can be mapped one to one easily. If the size of a ciphertext is lesser than the original length, so the mapping from all possible cases to the output will not be exactly matched. For example, if the input size is of 20 bits and output is 18 bits, so 82 raised to their combinations will be 2 raised to 20, and whereas the output combinations are 2 raised to 18. So there will be, for each 4 inputs there will be one output. So now next is the next encryption mechanism is the data encryption standard. So that is standard encryption policy in the symmetric key cryptography, where the key size is 56 bit. Generally the key size is 64 bit, but where the 8 bits are treated as the parity bits. So from the 64 bits from the 64 bits we use the 56 bit as the key size, and 8 bits are the parity bits. So in a DES, 64 bits chunk by chunk is encrypted one by one. So this DES and algorithm is provided by the NIST. So this one is the encryption algo. So in this encryption algo, there is a 64-bit plain text is there, and respective 64-bit plain text is there, as well as 64-bit key size is there. So both are passed to this DS algorithm, and 64-bit ciphertext is generated here. So the process is like, first there is initial permutation. So these 64 bits are passed to the initial permutation, and then we obtain again 64-bit output. So these 64-bit output is passed to this round 1, and from the key side, this 64-bit is left circularly shift, and again there will be permitted choice of the 64-bit, and those bits are passed to the round 1. So in each round there are total 16 rounds. There are total 16 rounds in DS algorithm. So from one side there is input text, and from other side there is key permuted key. So we apply any round operation over the input text and the key, and we generate the output, and this output is feeded as the input for the second round, and again we obtain the key from the key database. After all 16 rounds, there will be 32-bit swap, and then inverse initial permutation will be there, that generates the final 64-bit ciphertext. So we'll see how this ciphertext works. So basically this one is the initial permutation and inverse initial permutation. So these are the positions of the bits. So this one is 8 by 8. This one is 8 by 8 matrix. So where these bits are swapped with the other. So first bit will be here, second bit will be here, third bit will be here. So all the bits are permuted, and there is a standard. There is the standard initial permutation method, that is. Uh, Excuse me, just wait a time. Sorry for the interruption. Sorry for the interruption, participants. So we were discussing about we were discussing. So in each round, in each round there is plain 64-bit text. So this initial permutation is applied. So what is this initial permutation? So this table is provides the initial permutation as well as the inverse initial permutation. So this inverse initial permutation is applied at the end level. So this one is just a shuffling of the bits according to this table. So we shuffle these shuffle these bits according to this table, and we generate 64-bit output. That 64-bit output is divided into two parts. So how this round function works? So now after initial permutation, there is round function. So this 64-bit is divided into left 64-bit, left 32-bit, and right 32-bit will be there. So these are divided into two half of 32 bits parts, and there will be key of 56 bit. Actually the key is of 64 bit, whereas where 8 bits are the parity bits in the 64 bit. So we remove these parity bits, and 56 size bit are divided into two parts equally. So those will be 28 bit size. So each bit, this 28 bits are left circular shift, and second part is again left circular shift will be there. And then there will be initial there will be permutation correction of these 56 bits, and from these 56 bits we generate 48 bits, and these 48 bits are XORed with the expansion table. So what is this expansion table? So we are getting 32 bits of right hand side of the plain text after initial permutation. So this one is the expansion table in which there are total 32 bits. So we are increasing 16 bits extra. So converting this 32 bits to the 48 bits here. So these are the 48 bits, and these are the 32 bits. So we are just increasing the size from 38 to 48 with the help of this expansion table. And there is one permutation table is also there. That permutation works here. So in permutation, there is input is 32 bit and output is again 32 bit. So here there are 32. This one is 8 by 4 box, and these are the bit shuffling. So this one is the permutation. So we have discussed this method. We have discussed this. 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 Left circular shift for each and every 28 bits, and after shift we will apply this permutation correction choice. There will be one more table that will convert this uh, 58 bits to the 48 bits. Here the input is 56, output is 48. Okay, so how this S box works? So there is 48 bit input, and we convert this 48 input to the 32 bit input, 32 bit output using this S box, that is substitution box. So how this substitution box works? So in substitution box, there is a 48 bits and there is 48 bit key. Those are XOR, then there will be output of 48 bits. So we divide this 48 bits into 6 into 8. 6 to 8 is 48. So each 6 bit is converted to this. Each 6 bit is converted to the this 4 bits output. So what will be this? What is this S1, S2, S3? So S1, S1, S2, S3 are like 8 boxes. 8 boxes. So box has 4 rows and 16 columns. So these 16 values can be these 16 values can be converted. uh, we can we can map these 16 with the 4 bits. 2 raised to 4 is the 16, and the column is row is 4 rows. So 2 bits is needed to identify each and every row. So and output is of up to 16. So output is 16 means max 2 raised to 4 is 16. So these each and every block can be written by the 4 bits. So input are 1 bit, 2 bit, 3 bit, 4 bit, 5 bit, 6 bit. So these 6 bit identify one value, any one value, and this value is 4 bit output. This output can be represented by the 4 bits. Okay, so this one is the S box. So how to convert? So there will be 6 bits, first and last, means first and sixth will generate the row number, bit 1 and bit 2. So there will be 2 bit to identify the row, and 2, 3, 4, 5 intermediate 4 bits are used to identify the column number. Okay, so these are 6 bits used to identify row number and column number. Respective value will be there, that is of the 4 bit. So in this way these 6 bit are converted to the 4 bit. So 8 into 6, 48 bits are there, that generates 8 into 4, that is 32 bit. So we generate these 32 bit output from these 48 bits. So there are 8 S boxes. There are 8 S boxes, and respective values are given here. So we have to follow these S boxes. On the basis of these S boxes, we take the decision. On the basis of this S boxes, we take the decision and find the 4 bit output. Okay, so 8 X boxes are there, and which map 6 bits to the 4 bits, and outer bits 1 and 6 are the row selector, and inner 2 to 5 4 bits are the column selector. So we select a value from the table. That value is of the 4 bit, and we use those 4 bit to generate the result. So this one is the S box permutation. So for each and for each, so this one is one round. So 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 this one is one round, and in each round there are these operations. And after first round, left bit is XORed with this round operation output and stored to the right, converted to the right part, whereas right bits are as it is moved to the left side. So this one is the one round function. Okay, so left bit will be XORed with the right and stored to the right part, and this right is moved to the left side. So this one is complete one round function. So there is a left shift rotation and the right shift rotations are there. So as stated in this diagram, for each and every round there are 16 rounds. There are total 16 rounds. There are total 16 rounds. So there will be left circular shift for each round. So how many left shift circular shift? Those are defined by this table. So basically 1 to 9 and 16. 1 to 9 and 16. For 4 rounds, we use single one position left circular shift, and for the remaining all the rounds, we use the 2 bits circular shift. Okay, so for each round the number of rotations are defined here. Okay, so this one is the bit shifting for each and every round. Now we have to now discuss about the strength of the DES model. So this DES model is basically the DES model is basically reduction in key size of generally we use 128 bits, but whereas in DES we use the 56 bits. So we are reducing our model with the 62 bits. We are reducing our model with the 72 bits, and we apply the brute force mechanism. There are Xbox are classified. So we have to remember these Xbox, and this one is the weak point of this DES. So when we so in DS there is 56 bits key size. So total there will be 2 raised to 56 combinations. So exactly that will be 7.2 into 10 raised to 16 possible cases. So that is itself is very higher set of values. So trying each and every value means each and every task takes the time. So if we want to break using the brute force mechanism, so if you use brute force mechanism, then we will need we have to try these 7.2 into 10 raised to 16 values to attack that system. So if we apply this mechanism, if we apply this mechanism and the encryption speed is encryption per microsecond. So for example, for each testing each value, if we use 1 microsecond, then it will take more than 1,000 years to break the ciphertext using a general machine. If we are using general programming machine and each value takes per microsecond for each testing, then or to test all the cases 1,000 years to be needed to break this cipher mechanism. So this DES is the DS provides the avalanche effect. So what is the avalanche effect? So avalanche effect is like if there is a minor change in the plain text, if there is very minor small change in the plain text, then if there is very minor change, then output is completely changed. So minor change completely changes the output. So this DES exhibits a strong avalanche effect. So earlier DS, some researchers proved that this DS algorithm can be breaked in months, some states in days, and in 1999 there is one study that states that with the combined model supercomputer machine, this DS can be breaked in the 22 hours. So instead of using this plain DES, this triple DES is recommended. So triple DES means we are applying a DES 3 times. So the in plain DES the size is of 56 bits. So 56 bit multiply by 3, because when we apply triple DES, then the key will be triple. So there is 128 bits key will be there, and so this one is 112 bits more effective with compared to this DS. So this one is more standard, this one is more recommended with compared to that DS. And there are there are more encryption algos available in our cryptography. So you can a cloud service provider or a customer can opt any encryption algorithm for encryption and decryption. So we have seen some so how the stream cipher works, how the byte cipher works. So how what are the substitution mechanism, what is the transposition mechanism. Then we have also seen this DS mechanism. So all these mechanisms are for encrypting the text, encrypting the data, and that data is stored over the cloud. So when any customer need again that data, or client need that data, then he download that data and then decrypt that data with the help of this key. So here the key provides the security overall this key provides the security. So there are lots of techniques, cryptanalysis methods to break the cipher mechanism. So there is some limitations are also associated with the symmetric key cryptography. So in symmetric key cryptography, the same key is used for encryption and decryption. So if key is exposed, then if encryption key is exposed, then that is completely secure. Privacy is completely compromised. And one more limitation associated with this metric is how to provide that key to the recipient. So if there is a communication between client and server, or if there is any communication between two parties, then that single key should be shared between two parties, so that receiver can decrypt that message again. So how to share this private key is one major challenge in the symmetric key cryptography. There are lots of key sharing mechanism also there. Those provides the key exchange mechanisms. So we can use those key sharing, but we have to be consider this encryption. We have to be keep in mind these key exchange mechanism. Again, there will be one overhead over the cloud service provider to manage to share the keys. So next is asymmetric key cryptography. So in symmetric key cryptography, there was the same key for encryption and decryption, but in the asymmetric key cryptography, we use two different keys. We use two different keys, uh, one key for the encryption and another key for the decryption. So we name public key and private key as encryption and decryption. So as shown here, this plain text is encrypted with the public key of the receiver. So there is one public key of the receiver, and private key of the receiver is kept private by the receiver. So in asymmetric key cryptography, we apply the public key, and we apply the public key and over the plain text, and in the cipher mechanism, we convert this plain text to the cipher text using this cipher mechanism. Here we are using public key of the receiver. So this cipher text is either stored over the cloud, or it may be transmitted to the other party. So again, this cipher text is provided to the receiver. So receiver will apply the private key of the receiver. So private key of the receiver side. Okay, and this one is the public key of the receiver, and we are considering here this one is the sender, this one is the receiver. So we are using public key of the receiver to encrypt the data and transmit that data to the receiver, and private key should be always kept private, and public key should be available publicly. So that public key is available publicly, so sender can obtain this public key of the R and can encrypt the data with this public key of the R. And in decryption process, there is no need of this public key. So directly with the help of this private key, this text can be decrypted. Sorry. So in asymmetric key cryptography, there are some popular algorithms are there. RSA, Algol. So RSA is developed by Ron Reversed, Adi, and Len Edelman. So this one is key exchange algorithm as well as the encryption algorithm. So this RSA provides a key exchange and also the encryption. So the key size can be 512 bits, 1024 bits, 2048 bits. So variable key size can be used here. So there is one more algorithm, Algol. So Algol is developed by Tahir Algol, and again there can be the variable key length. So this RSA is more popular with compared to this Algol. So now we'll discuss one algorithm of this asymmetric cryptography, that is RSA. So how this RSA works? So how this RSA works? So there are two. So we have to choose two prime numbers P and Q, and we have to these prime numbers should be very large in size. So we have to keep in mind that should be large. One property is large. Second property is the prime number. So these P and Q should be larger in size, and then we have to compute this n such as P into Q. P into Q will be the n, and also we have to compute this Z. So what is Z? Z is P minus 1 and the Q minus 1. Okay, so we have chosen these two large prime numbers P and Q, computed n and computed Z. Now we have to choose a large number E that should be less than this n, and what is the property of E? That should not has no common factor other than n with this Z. So there should be no common factor between Z and this chosen E. So this E works as the encryption key. Again, we have to find one more number D, such as E into D. What is E? E is our chosen encrypted key. Now we have to choose D, and we have to calculate this ED minus 1. We have to calculate this ED minus 1 that is exactly divisible by this Z. So this time this E into D minus 1 should be divisible by this Z. Okay, so this D works as the decryption key. This E works as the encryption key. So what are these key are generated? This key are generated using this N, using this D, and this E. So the public key will be E. The public key is E, N and E, and the private key is N and D. So how this public key and private key works? We have generated two keys, E and D. E is a public key associated with the N, and D is a private key associated with this N. So encryption, we have seen that there is one encryption algorithm. We pass the plain text. And also we pass the key. So in encryption, this one is the encryption mechanism. This one is capital E, encryption mechanism is there. So here M is the plain text. E is the part of encryption key, N is the part of encryption key. So we have to calculate the ciphertext C. So this one is here. What is C? C is the ciphertext. Here M is our plain text. Actually, I am using the touchpad, so the writing through the touchpad is not so pretty or not so good. So this one is the M. So we are here M is the plain text, C is the ciphertext, where K is the key. So here key is E. Okay. So here key is E. So M raised to E mod N is the ciphertext. Okay. And at the receiver side, again we have to apply C raised to D mod N. Again we will obtain this plain text. Okay. So this one is the RSA algorithm. First we generate the key. And then we use this key for the encryption and decryption. Okay. So let discuss with this algorithm with one example. So first we have chosen two prime large, although we have to choose large prime numbers, but we are using here small size prime numbers. So we are choosing two prime numbers, 5 and 7 are there. So first we have to calculate N, that is 35, 5 into 7. Second we have to calculate Z, ZG, that is P minus 1 into Q minus 1. 4 into 6, that is 24. Now we have to choose E. We have to choose E and D such that for choosing E, the property for choosing E, that should be less than N. So our E is less than N, our N is 35. So this satisfies our one property. And the second property, that should not has no common factor with the Z. Okay, so 5 and 35. So there is no common factor between these two. Okay, and we have to choose D such that D into E minus 1 should be divisible by this Z. So E into B, 29 into 5 minus 1. So that is 184. So the 184 is exactly divisible by this 24. So our public key is 35 and E, N and E private key are 35 and 29. So we use this encryption mechanism. So the encryption mechanism is m raised to E mod n. So our m is, for example, our m is L. This one is the plain text. So we convert this plain text into the numerical value of the in a sequence, alphabetical sequence. So L stands at the 12th position. So we are taking here 12. So m raised to E mod n. So m raised to E is 24832 is there. And we have to apply the n. N is here 35. So we get mod n means we will obtain the value from 0 to 34. 0 to 34, 35 values will be there. So all values should be lesser than this. The all values should be lesser than this n. Okay, so m raised to E mod n will be the 17, and m raised to E mod n is again 15. So these are again these are like ciphertext values obtained here. So again we have to decrypt those values. So again these ciphertext values are here. We have to calculate C raised to D and then mod n. So C raised to D is given here. So this one is C raised to D. Our C is 17 and D is 29. So 17 raised to 29 is here. So we have to calculate C raised to D mod n. So when we apply the mod n, again we will obtain the value. So there will be 12. So this one is misprint. So there will be 12, and the value of 12 is again L. So okay. So this one is like a encryption and decryption using the RSA algorithm. So there again there is some weakness associated with this asymmetric key encryption. So what are these weakness? So in asymmetric key cryptography, 124 bits of asymmetric key is equivalent to the 128 bits of the symmetric key cryptography. But the issue with the symmetric key cryptography is key sharing. So then in symmetric key sharing is overhead over the symmetric encryption algorithm. But in asymmetric encryption algorithm, there is no need to share the key. So in asymmetric key cryptography, a man in middle attack can be there. So how this man in middle attack works? So there are two parties in asymmetric key. There are two parties, Alice and Bob. So they want to communicate with each other. So Alice encrypt the text with the public key of this David, and there is attacker Trude. So this Trude provides his public key to the Bob as a attacker, and this plain text is encrypted with this plain text is encrypted with the trader's public key that is decrypted by this attacker, and then again attacker provides his public key to this encrypt the data encrypt the data with his with David's private key and cipher the text and then forward to this David. Then David seems that this data is received. This attacker pertains to be David for the Bob and pertains Bob for the David. So he is the this attacker is the middle person. So Bob think like this one is the David, and this David thinks that this one is the Bob. So he give their pair, their public private pair, sorry, this give their public key uh, as a David to the Bob, and also gives his public key to the David as a Bob. So they encrypt the data. This Bob encrypts the data. This Bob encrypts the data with this trader's public key, and he is able to encrypt that data. Sorry, he is able to decrypt that data. So this entire process is the encryption process, and when this one is the again respond of that encryption. So again there will be one encryption and decryption, and again there will be one encryption and decryption. So in this way, this attacker attacks in between the David and Bob. So next is session key. Next is a session key encryption. So what is this session key, and what is this session key, and how this is encrypted? So this session key is used to improve the efficiency of overall encryption mechanism. This in symmetric key cryptography, this session key is used for the encrypting the data, whereas this asymmetric key cryptography is used to encrypting this session key. So we have to follow both symmetric key and asymmetric key for the encryption. Okay. So first this session key is encrypted with the RSA. RSA is the asymmetric key cryptography. We have discussed two algorithms, DES and RSA. So RSA is asymmetric key cryptography, whereas DES is symmetric key cryptography. So this plain text is encrypted. This plain text is encrypted with this session key, and this session key has to be provided to the recipient. So there is asymmetric key cryptography for sharing this key to the recipient. So recipient's public key will be there. Session key is as the plain text here. So first there will be session key transmission using this asymmetric key cryptography, and then so asymmetric key cryptography means encrypting the plain text with the receiver's public key. So this key is forwarded to the recipient. So this recipient decrypt this data with their private key and obtains the session key. Now there is plain text encrypted with this session key. So the cipher text is decrypted with this decrypted session key. So there will be decrypted session key will be here, and the cipher text can be read. So in this way, the session key is managed. For each and every session, the session key is shared with the help of asymmetric key cryptography, and then this asymmetric key is used for the encryption and the encryption. session key is used for encryption and decryption for sharing the plain data. So now there is a, so how to share their public and private key. So there is a key agreement. Diffie-Hellman provides the key exchange algorithm. So Bob sends Alice his public key. So each and every party publicly provide their public key. We have discussed this model here. So how to share this? How to share these keys with each other? So there are two parties, Alice and Bob. So they have to choose P, a prime number value, large prime number value that is known it, and a value A. So they have to be agree on two values, one prime value and one value A. Both chooses their own random number. These are the X, and for Alice, this random number is Y. So this has the Y as a random number. This has the X as a, this one has the X as a random number or private number. So both the parties compute a raised to x mod p. So for example, we find a raised to x mod p is like k1. So this one is k1, and again a raised to y mod p, that is the k2. Okay, so we have calculated k1 and k2 here. Okay, v means Bob has calculated this k1 and Alice has calculated this k2. Now they share these k1 and k2 with each other. So here this k1 will be forwarded to here, and this k2 will be forwarded to here. Okay, so again we have to calculate, means Bob has to calculate k2 k2 raised to x. What is x? X is chosen random number. K2 raised to x mod p, mod p, where p is the prime number. Okay, similarly this Alice calculates k1 mod p. They mutually agree on this p and a. Okay, so k2 raised to x means a. What is k2? K2 is a raised to y mod p. So a raised to y mod p raised to x mod p is equals to a raised to y raised to x mod p. And similarly a raised to x mod p raised to y, this y random number raised to y is equals to a raised to x raised to y mod p. So here a raised to y raised to x, and here is a raised to x raised to y. So both will be equal. A raised to, this will be a raised to x into y. So in this way they have identically shared their, identically they have shared their public key. They have shared the public key, and they kept their keys as a private key. So this one is the key exchange algorithm. Okay, so basically this key exchange algorithm or key agreement algorithm is provided by the Diffie-Hellman. This provided by the Diffie and Hellman. So this provide the ability for messages to be exchanged securely without having to be shared same secret information previously. So now authentication. So we have discussed in earlier lecture what is the authentication. So basically the authentication we have discussed till now, we have discussed some encryption mechanism by which we can secure our data. We can secure our data. Now there is a authentication of user should be there. So how to authenticate the user? So there will be some authentication mechanism. So authentication mechanism is basically validating the identity of a user from the central database. So there are three technologies or methods that provides the authentication. Either there is message digest, there is digital signature, and there is PKI, public key infrastructure. So message digest is equivalent also some kind of similar to MAC, that is a message authentication code. So we can authenticate user with the third party application. So there may be multiple third party application who authenticate the user and passes the token to access the resources or server. Or another method is there is centralized server or on premises server in which the IAM is maintained. So directly sender can produce their identity for accessing the resources. So what is the message? There is message digest. So what is the message digest? So message digest is kind of hashing mechanism. So where there is plain message, this plain message is passed to this message digest algorithm, and a digest message is generated from this message. So you can state that this one is the hash value of this message. So 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 this one is the just fingerprint of this message. And good hashing mechanism must have the avalanche effect property, such that if there is minor change if there is any minor change in this message, then this digest will be completely changed. Okay. So if there is any alteration in this test or modification is this message, so the message digest will be changed. This one is the property of the good message digest algorithm. So the purpose to use this message digest is to prove that the data has not altered. So this message digest process is also known as the hashing. So this hashing process is uh, irreversible. So once a message is converted to the digest, then there is no way to reobtain this message from this message digest. And for good hashing algorithm, there should be no possibility, or the possibility should be very minimum, such that for two same messages M1 and M2, the hash is the same. Hash or the message digest is the same. So this one is the property of the good hashing algorithm. So there are several hashing mechanisms are there, like MD5, SHA1, SHA2, SHA3, CACHEC 256. So these are several hashing mechanisms. Those are standard hashing, generates the message digest from the message. So that size of this message digest is always fixed irrespective of the size of the input message. So this one is the this hash is the fingerprint of this message, and this identifies that this message digest or this hash is generated from this message. So there is a next MAC codes, message authentication codes. So MACs are like in message digest there is secret key is also used. In general hashing mechanism there is no secret key is used, but in message authentication this message digest is created with the help of this key. So if there is, so in hashing anyone can compute this anyone, if the algorithm is known or any standard algorithm is there, then anyone can compute this message digest. Whereas in this message authentication course, the digest can be generated with the help of message as well as secret key is needed to generate this message digest. So again, at the receiver side, again, any party wants to verify that this digest is generated from this hash, then that party or receiver will also need this key. Okay, so in message authentication, a key is also associated to provide the privacy for generating this digest value. There is one more authentication mechanism, that is a password based authentication. So in password based authentication, a secret password is provided by the user to prove their identity. So there are some problems are associated with this authentications, there can be password can be learned from the social engineering. So generally what happens is user avoiding storing the old multiple password, they use the same password. If that password leaks at any social platform or any platform, then that is easier for attacker to obtain the password. And also a brute force mechanism or a guesswork can be there to break that password. So eavesdropping also can be there when communicating with the server. So there are several methods there are several methods which are used to attack the resources when the password mechanism is used. So we have discussed that multi-factor authentication can be used instead of this plain password or weak password. So the technique to improve our password is either we have to use complex password so that no one can break that password easily. There should be we can use challenge response mechanism. So that the server sends a random value to the client along with the authentication request. So client has to respond with their random value. That value is challenged, like captchas like things will be there. So if server gives the captcha as well as authentication request where user fills the request and also provides the captcha, so that also one challenge response kind of authentication. So a timestamp can be added, one time password OTP can be added. So next authentication method is the authentication protocols are there. So there is Cabros. Cabros is used for the authentication. So this provides authentication services. So when user wants to access the cloud services, then he has to use the Cabros authentication server to prove their identity. So prove their identity, and then Cabros provides the token to that Cabros provides the tokens to that user, and these tokens are used to tokens are used to find the access rights or access privileges which service can be accessed by the user. So a biometric authentication mechanism can also be used. So there are various biometric authentication mechanism like fingerprint recognition, voice recognition, handwriting recognition, face recognition, retina scanning, hand geometry recognition. So there are lots of biometric properties of a human that can be used for identity authenticating a user. So next one is the digital signature. So digital signature is again kind of message digest. Uh, Digital signature is again the kind of message digest that needs the sender's private key or the signer's private key. So there is digest algorithm. Okay, so message is sent to the digest algorithm, so that generates the message digest, and this message is signed with this private key. Means there is signing algorithm, and this private key of the sender is used to sign this message digest, and the digital signature is generated. So what is the use of this digital signature? When we want to encrypt our data, then we use the receiver's public key instead of sender's private key. Okay, the reason is like public key. First scenario is signing the message with the receiver's public key. So receiver's public key is available in public domain. So only receiver can decrypt that data with their private key. Okay. So for encryption, no one else can decrypt that data. So this for encryption, sender's public key is used to sender's public key is used to encrypt the data, whereas in the digital signature, sender's private key is used to encrypt the data by the sender. It means sender is signing the document digitally, and the sender's public key is available public in public domain. So this one is public domain. So sender's public key will be there, that is publicly available in the domain. So this public key is the public key can be used by anyone, and can verify that this public key, the sender's public key, is associated with the sender's private key. So if that digital signature, again there will be a message digest will be calculated, and that data will be signed with this public key. If both are same, if both digital signature are same, so we can state that this message is signed by the sender. So by this way we authenticate that only the sender can only sender can use the sender's private key to sign the digital signature, so sign the document. So this one is known as the digital signature. So this one is the method of digital signature. So there is one certification authority that stores the public key of the sender. So for these purpose we use the digital certificate. So there is a certification authority. So a digital certificate is signed statement by a trusted party that another party's public key belongs to them. So we use the CAs. There will be root CAs and there will be hierarchy of the CAs. So root CA, there will be some leaf lower level root CA is known as the top level, top tier CA, and then there will be lower level CAs. Then again there will be lower level CAs. So we contact any certification authority and ask about the ask about the public key of any signer. So we have to trust any party. So this certification authority provides us the public key, and a certificate that this public key is associated with this signer. So this one is the certification of this one is the certificate, digital certificate. So there is the chaining of the CAs. So for example, there is a top level CA, then lower level is B, and then again lower level is C. Then we directly knows the C. Then C authorize the B, provide the certificate of B. B provides the certificate of A. Then we contact the A. In this way, there is the hierarchy of CAs, and there is the chaining between CAs. So there is the chaining between CAs. So this one is similar, like there is one central organization that verifies the identity or the public identity of a person, that provides a certificate to a party that this party is the legitimate party. So it's essential. So it's essential a person's public key with associated with some identity informations, signed by authorities private key, and we authorities authorities private key is known to us. We use his public signed by the authorities private key. So we use this public key to verify the digital certificate of the sender. So with the help of this with the help of this certification authority, verify the certificate, and then use the trust. We have the trust on this digital certificate. So this one is the digital certificate chaining. So thank you, participants. I have covered lots of stuffs for the today's presentation. So now you may ask if you have any query regarding this presentation.
Participants, if you are having any queries, you can put up in chat box.
So Sujata, I think this Sujata was in last session in our earlier FDP on the blockchain. G Sujata.
I don't recall, sir. Sorry. Yes, sir. She was.
Okay. I remember her name. So her or his, I'm not able to identify. Uh, so and Gaurav Kumar Das was also there, na? In our earlier FDP on the blockchain and IoT.
Mm.
So, okay, thank you, participants. So, if you have
So,
any doubt, you may ask in the chat box or provide your doubts to the uh, host of this FDP, to Mr. Agam, and he will convey the message to me, and we will continue accordingly.
so thank you once again, sir, for contributing to our FDP. The information that you gave were truly insightful. So thank you once again, sir, for being part of this.
Okay, thank you, Agam.
Sir, there is a question from Sujata, ma'am.
Yeah. So, what quantum computing security mechanism can be best for cloud computing security? So I am sorry, Sujata, I am not much aware about this quantum computing security mechanisms. Although that is related to some superimposed qubits, and there are qubits, and there is one new state, quantum bit state. So that is superimposed, but practically this one is not feasible right now. There are lots of research is going on the quantum computing, but there is in practical aspects to implementing that third state qubit or superimposed state is not feasible. So work is going on, and I am not much aware about any security mechanism related to the quantum computing that uses the quantum computing. Obviously this quantum computing security mechanism will be better if that is available, because in our traditional model there are only two bits, 0 and 1, but in the quantum computing there is a third bit, qubit, so that changes their behavior according to the requirement. So obviously the speed will be much higher in the quantum computing security mechanism. But for the quantum computing security mechanism we will need one dedicated hardware that is able to compute these superimposed states. Yes.
Any other participants? If any queries, please put up in chat box. So, sir, I think there are no more queries,
Okay,
so
then.
we can conclude now. Thank you, sir.
Okay, thank you, thank you.
So,
Thank you.
so to the participant, the next session will start at 4 p.m.
Okay, thank you, Sujata.